Let's take a look at some different forms of linear equations. Suppose that I'm given a point and the slope of a line and told to put it into different forms. I think the easiest one to go with is point-slope form. And point-slope form looks like y minus y sub 1 equals m, the slope, times x minus x sub 1. Now the y sub 1 and the x sub 1 indicate specific values of x and y. In an ordered pair, we're given specific values of x and y. So let me go ahead and write this equation in point-slope form. I'll write y minus my y value from the ordered pair, 5, equals the slope, 2, times x minus the x value from the point. Let me write that in the box. Now once I've got something in slope or point-slope form, it's really quite easy to turn it into slope-intercept form. I'm going to start by distributing the slope to the two terms inside of the quantity. So I'll have y minus 5 equals 2x plus 0. Now I'll take and add 5 to both sides because I'm solving for y. And y is going to equal 2x plus 5. And that's in y equals mx plus b form, slope-intercept form. Finally, to get to standard form is of the form ax plus by equals c, where the coefficient of a is non-negative and it's an integer. So if I start with y equals 2x plus 5, and I say, okay, I'll move the 2x to the other side, I end up with something very close to standard form. And I don't have a positive integer as my coefficient of the first term. So I've got to do something creative here. I've got to take and move the negative number by multiplying by a negative 1 throughout. And I'll have 2x plus a negative y equals negative 5. And that's in standard form. Let's look at another example. If I've got something that is in standard form, 3x plus 4y equals 8, and I want to change it to slope-intercept form, I would have to solve for y, so I'll subtract 3x from both sides, and I'll have 4y equals negative 3x plus 8. Now I'll divide by 4. I've got to divide the whole side by 4, and I'll have y equals negative 3/4 x plus 8 divided by 4 is 2. Now once I've got that, I've got the slope, I can write that m is negative 3/4. But I wonder about having a point. And let's take this point that we do have. We have the intercept, which actually stands for the y-intercept. And the y-intercept is actually a point that goes through the y-axis. If we had a coordinate plane, this point would be at 0, 2. And that's where we would put our mark. So the 2 indicates a point at 0, 2. I can write point-slope form very quickly after that. Let's look at the next one. If I have something in slope-intercept form, I can write the slope. I can write a point, 0, -2, and I can write point-slope form. Minus -2 is going to become +2 equals the slope 3 times x minus 0. I can also convert this thing into standard form pretty quickly by subtracting 3x from both sides. And then multiplying the whole thing by a -1. And I end up with 3x plus a -y equals 2. Let's go from point-slope form. The first thing that we know is we have the slope, and our slope is 3. So I'll write m is 3. I also have a point, and that point is 2, -4. It's -4 because I would have to go minus -4 to get x plus 4. Let's convert it from point-slope form to slope-intercept form. Y minus 2 equals -3x plus 12, negative. Let's add 2 to both sides. And y is -3x plus -10. Now if I've got this in in slope-intercept form, I can get the standard form very quickly. I can add 3x to both sides. And since it's going to end up positive, I won't have to do the multiplication thing. I'll have 3x plus y equals -10.